Hello everyone, welcome back. Last few lectures we have seen and we have started something about an important concept of environmental studies, and during these concept studies we have gone through some of the major components, and these major components which are related to environment and which are related to human should interact with one another in same form. Also, we had seen one of the important criteria of how gases components. Okay, these gases components, how do these gases components have an effect on human life, on atmosphere, as well as how does these gases effect directly and indirectly affect the environment, which in turn will again affect the human life system. So that is what we have seen. Now, why am I saying something about these gases component is reason because today we are going to see a very new and awaited concept for our lecture. And this awaited concept is nothing else but, as we had discussed, about the nuclear accidents. Friends, keep in mind this concept is, even though looking very much easy, yet I would rather say that you should give also much focus on this concept. Reason for is because many questions have been raised till today in your final examinations and in your class test regarding the nuclear accidents. This concept, even though sounds to be very much familiar to you, yet it carries much important criteria for understanding. Reason because is many questions have been created or have been asked which are very much confusing, and to look forward for this confusion or to move on rather than from this confusion, we have to look forward for nuclear accidents in detail. So as I promised you that we are going to discuss some of the nuclear accidents, and of course the nuclear accidents which are given to us for our syllabus are is not belonging to any of the Indian accident, but rather I would also suggest you that you should selfly study some of the accidents which took place in India or in Asian continent for that case. Reason is because any sort of question can be raised at point also. So before understanding any kind of nuclear accident which took place in the countries like Soviet Union, or maybe like China, or maybe like Three Mile Island, United States, etc., etc., you should have one thing very much clear for you, that nuclear accidents do have some of the terminologies, and these terminologies is important to be cleared, because if you don't understand, if you don't clear up these terminologies, it becomes very much complicated process to understand these accidents. So rather we would first study some of the basic terminologies which is related to nuclear accidents, or rather I would say nuclear explosions, and how these explosions were taking place can be understood by these simple concepts also. So you are aware with some of the concepts, but yet to revise we are going to look forward for these concepts. Again, whatever the slides are being represented today, I would suggest that you are going to take down each and every point in a note form. Reason is because questions are asked now and then. इवन इफ इट साउंड्स वेरी सिंपल, आप लोगों को लगता होगा कि फाइन मुझे एटम पता है, मुझे केमिकल पता है, मुझे न्यूट्रॉन पता है, आपको सब पता है, आई डू एग्री विथ इट, बट जिस टाइम क्वेश्चन आता है उस टाइम हम कंफ्यूज हो जाते हैं. रीजन बहुत सिंपल होता है, क्योंकि हमारे पास 4 ऑप्शन होते हैं और चारों ऑप्शन बहुत ज़्यादा सिमिलर साउंड करना शुरू कर देते हैं. हेंसफोर्थ आपको ये काफ़ी नोट डाउन करने का पॉइंट है. Let's move on with the very first concept, and that concept is known to everyone, that is called as atom. Now atom is a concept which you people have studied in the chemistry very previously, so it is not a new concept, but what I am going to tell you is something new about it, like who invented atom, or when was the atom being first called on, what is the actual area, why we have to study the atom from the nuclear point of view or nuclear accident point of view. So, atom basically is a word which was coined from by a Greek philosopher. we think that it is something related to scientific study. Yes, it is related to scientific study, but इसका सबसे पहला नाम जो दिया गया था और इसका सबसे पहला जो स्टडी हुआ था वो एक ग्रीक फिलोसोफर ने किया था अराउंड इन 5th century BC, and this was actually a Greek word. So when it is a Greek word, it is not a simple kind of word like we write it as atom. It is rather was called as atmos, which was meaning uncuttable, that means which cannot be broken down, was a concept given by the philosopher called as Leucippus and his one of the student, that is Democritus. So this was the concept both explained that this is particle. For example, it's shown in the picture that this is a particular kind of a atom, and according to these people, this particular atom, okay, it is made up of protons, electrons, neutrons. So we know this concept is very much clear to us, but what they told that this cannot be broken down into further element, and henceforth whatever we see or whatever we feel, maybe it is a solid or liquid or gaseous or even a vacuum state according to them, or even a plasma state according to them, is having a stable condition for the reason because this cannot be broken down. This concept was further on studied, and it was then deviated that it can be divided, or atom and electron can be shared. So we had seen this part, if I'm not wrong, you remember that we have seen this part in a part called as acid rains also. Also we have seen in the part of ozone depletion. So I've shown you something in the ozone depletion, that how ozone is formed and how O3 and O2 acts with chlorine or nitrogen or sulfur compounds. So similar is the term which is being explained over here. So ozone can act similarly, that means an atom can act. So this study was given later on, but what these people found out, that it was named as, that means they found out an element, and this element was containing 2 to 3 major elements in it, and these elements were nothing else but proton, neutron and electron. Now these were the charged material. So we know that these are the charged material, and we also know that there is something called a covering for it, and this covering was composed of, or it is composed of protons specially and neutrons, and which is intacted or which is enclosed is called as a nucleus. So nucleus is made up of something called as a proton and neutron, and on another hand the electron is a part which is completely revolving around the proton and neutron for its retention, that means for its exchange or for its capability to accept something. So that was a role of electron. Now let's move on with the second concept, and this second concept was called as a fission product. Okay, now from here we start something called as nuclear accident. So you have to keep in mind these concepts very well, because fission was a question asked in the last examination. So basically fission, as the word describes, it's something breaking down or splitting down. So splitting down of nucleus, split क्या होता है या फिर breakdown क्या होता है, तो न्यूक्लियस ब्रेकडाउन होता है. ओके, अब आप सोच सकते हो कि न्यूक्लियस कैसे ब्रेकडाउन होता होगा. रीजन इज बिकॉज हमारे पास एक पहले स्लाइड में हमने देखा था कि इलेक्ट्रॉन्स आर कंटिन्यूसली मूविंग. सो इफ यू रिमेंबर दैट द इलेक्ट्रॉन्स आर प्रेजेंट इन द आउटर शेल, एंड दीज इलेक्ट्रॉन्स get shared with the other electron material or with the another atom material. Because they get shared, that means शेयरिंग होता है. शेयरिंग की वजह से इलेक्ट्रॉन लूज हो जाता है, और इलेक्ट्रॉन लूज होने की वजह से क्या हो जाता है कि न्यूक्लियस गेट्स ओपन अप टू द सरफेस एरिया वेयर द हीट कैन एक्ट ऑन इट. सो अगर किसी सरफेस एरिया, फॉर एग्जाम्पल सोच लो कि दिस इज वन ऑफ द एटम and it is having a the center part which is covered up. Now this is completely covered up with the electrons and then neutrons and then protons, and nucleus में होता है proton and neutron. So electrons इसे protect करके रख रहा है by either accepting or by either giving up. But if the electrons are continuously being removed out, what will happen? Nucleus will be exposed to the heat energy or any other kind of energy, due to which what will happen? The nucleus itself will break down. Now what happens when the nucleus breaks down? There is a generation of energy. Okay, so जितना बनने में एनर्जी नहीं लगता है उतना ज़्यादा एनर्जी जब न्यूक्लियस ब्रेक डाउन होता है या फिर स्प्लिट हो जाता है वहां पे एनर्जी क्रिएशन होता है, एंड दिस इज कॉल्ड एज fission process. So breaking down of nucleus will be called as a fission process. You have to keep in mind, fission process gives out energy which is very much in amount. That means tremendous amount of energy is given. So this is basically a process which is used in you can say energy generations. So for example, if you are going for the generation of electricity, many of the electricity generators are using the process of fission process. Okay, so that is one method. Similarly, in many of the if not if atom bombs, if you have heard something about the atom bombs, atom bomb uses the fission energies only. दैट मीन्स एटम बॉम्ब का एक्सप्लोजन बहुत लाउड क्यों होता है या फिर एटम बॉम्ब से एनर्जी ज़्यादा क्यों इमिट होती है और एटम बॉम्ब से सबसे ज़्यादा डिस्ट्रक्शन क्यों होता है, तो वन ऑफ द रीजन इज बिकॉज न्यूक्लियस ब्रेक डाउन होता है. तो न्यूक्लियस जहाँ पे ब्रेक डाउन होगा वहाँ पे सबसे ज़्यादा एनर्जी क्रिएट होगा. फॉर एग्जाम्पल यूरेनियम एंड प्लूटोनियम. So you have to keep these two components or two elements very much fixed in your mind, that these two components, that is uranium and plutonium, or plutonium let's say, they basically are being used in nuclear power stations. So I've said like if you are generating an energy, आपको uranium और plutonium use करना होगा, especially the rods of uranium and plutonium are used. So we'll see the uranium and plutonium rod and its study in when we will look actually for the nuclear accident, one typical kind of nuclear accident. But at present you have to keep in mind that जहाँ पे न्यूक्लियर पावर जनरेशन होता है, यहाँ पे बहुत ज़्यादा पावर जनरेट किया जाता है विथ यूज ऑफ material that is uranium or plutonium, it becomes very difficult to control that reaction. Reason is because न्यूक्लियस बहुत इंस्टेंटली रिएक्ट होते रहता है, बहुत इंस्टेंटली उसे एनर्जी प्रोवाइड की जाती है ताकि न्यूक्लियस ब्रेक हो जाए. और जितना ज़्यादा न्यूक्लियस ब्रेक होगा, जितना फास्ट न्यूक्लियस ब्रेक होगा, उतना ज़्यादा एनर्जी इमिटेट होगा. सो इसीलिए यूरेनियम प्लूटोनियम कहाँ पे यूज होता है, तो न्यूक्लियर पावर स्टेशंस में. फिशन कहाँ पे होता है, एटम बॉम्ब्स में फिशन प्रोसेस होता है. ओके, fine. So we'll understand something about the opposite term of fission. So when it is fission, nucleus break हो रहा है, but when it is fusion, that means a combining of nucleus takes place. जहाँ पे fission में nucleus break होना शुरू हो जाता है. So you can see over here in this picture, जैसे हमने fission में देखा था, nucleus के break down होना शुरू हो जाएगा. फ्यूजन इटसेल्फ का मतलब होता है मिक्सिंग. सो मिक्सिंग में क्या होगा, 2 or 3 or more than 2 or 3 elements, they come together, and how they come together, the nucleus gets combined. Okay, so for example, this is plutonium, then thorium, helium, all these components, they come together. अब ये एक साथ क्यों आ सकते हैं, रीजन इज वेरी मच क्लियर, बिकॉज इसके आउटर कवरिंग या फिर आउटर शेल में जो पार्टिकल होता है वो कौन सा होता है, इलेक्ट्रॉन होता है. और इलेक्ट्रॉन का कैपेसिटी या फिर इलेक्ट्रॉन का मेथड क्या होता है किसी भी चीज के साथ कंबाइन होने के लिए, बहुत सिंपल मेथड होता है, दैट इज समथिंग ऑफ एक्सचेंज. सो इलेक्ट्रॉन्स जब एक्सचेंज होंगे तब दो कंपोनेंट्स कंबाइन होना शुरू हो जाते हैं, और जब दो कंपोनेंट्स कंबाइन होना शुरू हो जाते हैं इसका मतलब होता है उसका न्यूक्लियस भी स्लोली कंबाइन होना शुरू हो जाता है बाय एक्सचेंजिंग ऑफ इलेक्ट्रॉन्स एंड देन प्रोटॉन्स, एंड देन इट कंबाइंस टुगेदर टू फॉर्म अ सिंगल न्यूक्लियस. सो अ क्वेश्चन अराइजेस, अगर फिशन में एनर्जी जनरेट होता है तो क्या फ्यूजन में भी एनर्जी जनरेट होगा? सो आंसर इज यस, फ्यूजन में भी एनर्जी जनरेट होता है, बट कंपेयर्ड टू फ्यूजन it is not that dangerous. It is dangerous. I'm not saying it is not that dangerous. Okay, so it is dangerous, but comparatively less than to fission process. This fusion process you can see basically in sun. For example, when two hydrogen combines, it brings and forms a new atom, and that will be called as a helium atom. So that is nothing else but a fusion process. So ये process बहुत huge amount of energy लगता है. So इसीलिए ये process usually nuclear power reactors में use नहीं होता है. It is a very natural process, but it is not used in nuclear power stations for the reason because जहाँ पे energy ज़्यादा लगता है वहाँ पे energy आपको ज़्यादा देना पड़ेगा, right? For example, consider that if you are going to apply and energy of if you're going to heat an iron, then only you can press up your clothes, correct? So that is giving energy and then trying to utilize it. But consider how can this take place in an energy generator? It is impossible. Reason is because जितना ज़्यादा energy दोगे उतना ही energy आपको मिलेगा. So what is the profit? Nothing. So it is zero. So this does not takes place in any of the nuclear reactors. Then where does it takes place? So it takes place basically in a kind of nuclear weaponaries. Okay, so जहाँ पे nuclear weaponaries use होता है, for example thermonuclear weaponry, especially आपको ये याद रखना है. So it is also known as thermonuclear weaponry because it is consuming large amount of energy, and it is one of the energy by generation of thermal reactors. So जहाँ पे 2 हाइड्रोजन combines होंगे वहाँ पे energy generate होगा, but कैसे form में? combine होने के form में, और बहुत ज़्यादा energy लगता है, henceforth it is not used in nuclear reactors. Fine. The next important concept, and that is called as radiation. So radiation is something means emission or transmission of energy. Now this emission or transmission, for example हमने एक प्रोसेस देखा था या फिर आप लोगों को पता होता है एक प्रोसेस that is called as photosynthesis. In photosynthesis, sun is giving out the energy and plant is capturing it. Okay, so the role of the sun is emission of energy or transmission. That means carrying of the energy from one source to another source. So either the source is available for the sun to take the energy or not, it's not the problem of a sun. But sun is doing its work, that is it is giving out radiation, it is emitting out energy, and this energy can be either in a form of a wave or in a form of a particle. Now what do you mean by in a form of a wave or a particle? Is reason because what kind of energy, what wavelength of energy and what medium through which the energy is being passed shows what sort of transmission medium is. So if it is water, it will be in a form of a wave. Sorry. So if it is atmospheric condition, it would be in a form of a particulate form. Now this again changes, okay, because depending upon the space, depending upon the atmosphere, depending upon the conditions, climatic conditions, for example if it is cloudy, you can't get a sun rays directly, so it will either filter up and then it will evaporate itself or transmit itself and it will return back in the atmosphere level, or in some cases, rare cases, when there is less cloudy area, it can come, but it is in not that harsh form as compared to summer season. So radiation is emission. So like I said, radiation can take place in 4 different forms. Now these depending upon the states of condition of your material or your area or your situation, this changes. For example, if you look forward for electromagnetic radiation, you can see that this electromagnetic radiation takes place with the help of radio waves. Okay, so these are basically radio waves and these are calculated in a form of wavelength. So आपने physics में पढ़ा होगा ये concept, that is wavelength. So it is wavelength having a very smaller part, grooves, which we call it as grooves. So these are calculated in the form of a groove. So it is larger groove or smaller groove, and that is nothing else but called as a wavelength. So हम usually radio adjust करते हैं. If you sometimes have used a radio, even in your mobile phone we have a system of radio system. So we usually what we do, we match the frequency, right? So matching this frequency means we are matching the electromagnetic radiation. We are trying to capture the electromagnetic radiation and get connected with that radiation. So electromagnetic radiations are most probably used in radios, microwaves, and these are the radiations which are more used rather compared to any other kind of radiation, because we are techno oriented. So we have a satellites, and satellites do give out electromagnetic radiations. Next radiation form is called as the particle radiation, and these particle radiations are basically in a form of small particles. Like we have seen the electron, neutron, proton, nucleus. These are nothing as particle radiation. So in what pattern they transmit or they flow to another source can be identified as alpha, beta and gamma sources. So basically the alpha sources have a very low probability of passing either through a paper or so. Even in some cases it is studied the alpha particles cannot penetrate through your skin also. But if ingested, okay, that means अगर आप inhale कर लेते हो या किसी सोर्स के थ्रू अल्फा पार्टिकल आपके बॉडी में चला जाता है तो वो सेल को डैमेज करने की कैपेसिटी है, बट वो आपके स्किन को पेनिट्रेट नहीं कर सकता है. On the other hand, beta radiations में थोड़ा ज़्यादा पावर होता है, so it can actually penetrate any kind of a thin paper or sheet material, but it cannot penetrate through a material which is either a aluminium, iron or steel material. So hard material को penetrate नहीं कर पाएगा. Of course, skin को penetrate कर सकता है beta radiation, and gamma radiations are having more strength as compared to that of alpha and beta radiation. इसमें जीरो न्यूट्रॉन होता है पूरी तरह से, एंड बिकॉज ऑफ दिस कैपेबिलिटी इट कैन इजीली इवन पास थ्रू हार्डेस्ट मटेरियल which is seen on the earth. So it is possible that gamma radiations are present all over. Henceforth, usually हम जो बोलते हैं that you have to protect yourself from the sun radiations, that is harmful radiations, UV radiations. This is one kind of source, because it can penetrate through your skin also, then it can penetrate through your bones also, to your cells, to your muscles, even it can flow on with a particulate in a particulate form from with your blood, so it can pass easily, and that is the reason you have to keep in mind that gamma radiations are more difficult as compared to alpha and beta. The third one, that is called as acoustic radiation. Now this is basically a concept which is very new to, not that difficult to understand. The reason is you people might have sensed something about the ultrasound, okay, which is used in the process of medical terminologies. For example, if there occurs a patient, usually the doctors recommend to do an ultrasound. That means for testing the in-depthness of the disease. This process is basically done. So what is that? It is a kind of a sound source energy which is being passed on from into the human bodies, due to which for example X-rays, अगर आप देख लो, it is one of the kind of sound energies only. It enters and it gets up to your body part, and then it gives out the resultant, what you see in a form of a picture or in a form of a video on a screen. That's ultrasound radiation. The next, even though ultrasound radiation can also be found in some transmission mediums also, okay. So for example, loudspeakers, that is nothing else but a ultrasound radiation form only. So you can, even though we feel like it is mic which is being providing us a loud sound, but how does it work? It works on the category or categorization of acoustic radiation, that is sound medium. So acoustic का मतलब याद रखना है आपको, sound. The last, and this gravitational radiation is used basically by geotechnicians. So geotechnicians are nothing else but the people who study the earth. So for example, they give out the with the help of these gravitational radiation, they give out something about the study of earthquake, right? So you might have seen Richter cells. So when an earthquake occurs somewhere, they give us the concept that यहाँ पे इतना इतना रेक्टर सेल्सियस में earthquake आया था. How do they measure it? With the help of gravitational radiation. So wave motions or changes in the plates or changes in the situations of the earth. For example, particular earth is having a solidity, low solidity, very low liquidity, etc., can be studied with the help of gravitational radiation. So this is nothing else but a picture of alpha radiation. So it becomes easy for you people to understand how the alpha particles move. So alpha particles basically undergo a very easy decay process. रीजन इज बिकॉज जैसे मैंने आपको कहा था कि इट इज अ वेरी सिंपल component. It is not that complex component. It is just made up of a proton and neutron. Of course electrons are present in, but they easily share their electrons. कोई element, for example जैसे हमने ओजोन देखा था, easily they can share. Okay, so O3 easily share हो जाता है किसी के साथ भी. अगर दो हाइड्रोजन मिल जाते हैं तो it easily becomes shareable form, combines with H2 to form H2. On another level also combined with, so it can easily combine. That is something about alpha radiation because it is having a charge. That means electrons है, protons है, जो काफी इंटरैक्टिव होते हैं, जो काफी इजीली इंटरैक्टिव हो सकते हैं, इसलिए ये ज्यादा पेनिट्रेट नहीं करता है. ओके, सो जैसे हमने कहा था, इट इज नॉट इजीली पेनिट्रेट. इट कैन ओनली पेनिट्रेट थ्रू अ लेवल ऑफ पेपर, that much capacity only, or skin cell. But also conditions apply that in which area you are standing. So if there is a radiation amount more of alpha and you protect yourself from these radiations by any of the sources, such as maybe coating or sun coats or shirts or any etc, etc, you'll get protected. But if by chance it gets into your body, will not be protected by these sources also. So beautiful examples of alpha radiations can be uranium 238, radium 236, plutonium 239 and polonium 210. Why have you given this substance or these particles is because these particles were the asked questions. Similar goes with beta radiation. So beta radiations में maximum क्या होता है, इसे इलेक्ट्रॉन मैक्सिमम होता है, इसे पोइस्ट्रॉन भी कहा जाता है. सो ये आपको याद रखना है कि इलेक्ट्रॉन बहुत ज्यादा होता है और इसे पोइस्ट्रॉन भी कहा जाता है. ये काफी पेनिट्रेट कर सकता है इजीली पेपर में से. कई बार कोई लोग ज्यादा सेंसिटिव हो जाते हैं स्किन के केसेस में, तो उनके स्किन के पेनिट्रेशन में बहुत ज़्यादा बीटा रेडिएशन भी रिलीज हो सकता है. बट इसकी वजह से सबसे बड़ा प्रॉब्लम जो होगा वो होगा रिस्क ऑफ कैंसर. ओके, so that is one of the threat which may occur because of these kind of radiation, because they can easily penetrate into your skin. So ingesting problem भी हो सकता है अगर ये indirectly आपके बॉडी में insert हो जाता है from in a part of food material or drink material etc etc. So beta radiation difficult हो सकता है आपके digestions में भी. Gamma radiations on that part is more difficult as compared to alpha and beta because it is one of the unstable kind of component. It is very unstable. Unstable in a sense because it has a very intense energy. Photons बहुत ज़्यादा unstable होते हैं, काफ़ी ज़्यादा emit करते हैं energy को, mass काफ़ी ज़्यादा release out करने की कोशिश करते हैं, जिसकी वजह से ये आसानी से पेनिट्रेट हो सकते हैं थ्रू द टफेस्ट पार्ट ऑल्सो. इसका सबसे अच्छा एग्जाम्पल होता है दैट दे कैन इवन पास थ्रू द कंपोनेंट्स विच आर मेड अप ऑफ लीड. That means it is a tough part, but it can pass through these components also. So it is one of the toughest of energies radiating. Form. The next part is this. In this part you can just see what I have told you, that alpha, beta and gamma. So it gives you an idea that alpha पेपर में से जा सकता है, बीटा थिक शीट में से पास हो सकता है कभी कभार अगर डिपेंडिंग ऑन सिचुएशन कंपोनेंट लीड ऑल्सो. नेक्स्ट पार्ट इज कॉल्ड एज चेन रिएक्शन. सो समझने की काफी इजी हो जाता है अगर आपको फिन और फ्यूजन समझ में आ गया हो. चेन रिएक्शन इज नथिंग एल्स बट इट इज अ प्रोसेस of giving off of energy या फिर रादर मैं कह रही हूँ ट्रिगरिंग ऑफ एनर्जी। दैट मीन्स आपके पास एक एटम है जो कि इलेक्ट्रॉन, न्यूट्रॉन, प्रोटॉन से भरा हुआ है एंड वो क्या है, फिशन प्रोसेस जा रहा है, इट इज ट्राइंग टू ब्रेक इटसेल्फ। अब ब्रेक क्या होगा, न्यूक्लियस ब्रेक होगा। न्यूक्लियस ब्रेक होने पे क्या होता है, एनर्जी रिलीज करेगा और ये दो पार्टिकल्स में बढ़ जाएगा, दो से ज्यादा पार्टिकल्स में बढ़ जाएगा एंड देन इट विल गिव इट्स एनर्जी टू एन अनदर न्यूक्लियस टू ब्रेक डाउन, then it will give an another nucleus, then it will give another nucleus। so ये ऐसे कंटिन्यू चलते रहता है। इसी वजह से जो एक्सप्लोजन्स होते हैं बहुत वास्ट या फिर बहुत ज्यादा हार्मफुल, वो इसके वजह से होता है, बिकॉज इट गोज इंटर चेन रिएक्शन। चेन रिएक्शन को स्टॉप करना बहुत ज्यादा डिफिकल्ट हो जाता है और न्यूक्लियर रिएक्टर्स जो हम एक्सीडेंट स्टडी करने वाले हैं, इसका प्रॉब्लम भी यही है कि न्यूक्लियर रिएक्शंस को कंट्रोल नहीं करते आया था बिकॉज ऑफ कंटिन्यूस रिएक्शन जो बार बार फ्रॉम वन पार्ट टू अनदर पार्ट, इट वॉज कम्प्लीटली अनस्टॉपेबल। सबसे बड़ा प्रॉब्लम रिएक्शंस का और एक होता है दैट अगर वाटर के कांटेक्ट में आ जाता है, सम पीपल थिंक दैट इट इज वन ऑफ द मोस्ट मिसकंसेप्शन विच इज कंसिडर्ड कि अगर पानी डाल दो तो इट विल स्टॉप इट्स एनर्जी, बट एक्चुअली समटाइम्स इट एक्सप्लोड्स, सो दैट इज अ बैड ऑफ फिशन प्रोसेस। तो ये हमने पहले भी डिस्कस किया था, दैट इज बॉम्ब एंड हाइड्रोजन बॉम्ब, एटम बॉम्ब फिशन करता है एंड हाइड्रोजन बॉम्ब फ्यूजन करता है। ओके, सो ये आपको सिर्फ डिफरेंशिएशन याद रखना है। सो एटम बॉम्ब के लिए याद रखो एग्जांपल दैट इज प्लूटोनियम एंड यूरेनियम। ऑन अनदर हैंड हाइड्रोजन के लिए याद रखो फ्यूजन विच इज टेकिंग प्लेस बिकॉज ऑफ हाइड्रोजन, दैट इज दो हाइड्रोजन, इसे ही हम थर्मोन्यूक्लियर रिएक्शंस भी कहते हैं। कंट्रोल्ड रॉड और कूलेंट ये सबसे ज्यादा इंपॉर्टेंट होता है किसी भी न्यूक्लियर एक्सीडेंट को स्टडी करने के लिए या फिर किसी भी न्यूक्लियर रिएक्टर को स्टडी करने के लिए। कंट्रोल रॉड वो केमिकल प्रोसेस होता है या फिर वो रॉड होता है जो केमिकल प्रोसेस क्रिएट करता है, आपकी रिएक्शन जनरेट करता है, किस चीज के लिए, एनर्जी जनरेशन के लिए। ओके, कोई भी रॉड जब इमर्स होता है, जैसे हमने पहले इसमें देखा था कि हम एनर्जी जनरेशन न्यूक्लियर के लिए यूरेनियम और प्लूटोनियम यूज करेंगे। तो क्या होता है, ये रॉड इमर्स होता है और इन रॉड्स के साथ क्या किया जाता है कि एनर्जी पास ऑन किया जाता है, दैट मीन्स इसे रॉड्स को एनर्जी प्रोवाइड किया जाता है जिसके इनके न्यूक्लियस ब्रेक डाउन होना शुरू हो जाते हैं रॉड में के, और वो अमाउंट ऑफ एनर्जी जनरेट करता है वो बहुत ज्यादा होता है। सो दैट इज नथिंग एल्स बट न्यूक्लियर रॉड। कूलेंट क्यों होता है, कूलेंट मोस्ट ऑफ द टाइम, not sometime, it is most of the time used as a water। so ये water coolant बोल के क्यों यूज किया जाता है, ताकि आपकी रिएक्शन को कंट्रोल किया जा सके। ओके, सो वाटर अगर ज्यादा हो जाए तो एक्सप्लोजन होता है, कम हो जाए तो भी एक्सप्लोजन होता है। किसका एक्सप्लोजन होता है, रॉड्स का एक्सप्लोजन होता है, मतलब कंट्रोल रॉड्स एक्सप्लोड होना शुरू हो जाते हैं। सो कूलेंट प्लेज एन इम्पॉर्टेंट रोल इन कंट्रोलिंग योर न्यूक्लियर रिएक्शंस एवरी टाइम। so you have to keep these concepts in mind, so when we have to look forward for the accident, till then study hard.